But who do we have next?
Next, we have people from S Group and AWS. Yesterday, we were asking Paul which track is the most interesting track for people who joined yesterday, and the majority said cloud and serverless. So here we have cloud and serverless. We have, for those people who don't know, S Group is a grocery store chain, a co-op chain with more than 1,800 outlets. And here we talk about S-kaupat.fi, which is an online grocery store. And on stage we have Kirsi Louhelainen, who is a senior solutions architect at AWS, and Niko Kivelä, who is a principal DevOps architect from SOK, which is the company behind S-stores. So we are going to learn on tooling and structure that was required to build the store, the S store, around CI/CD, deployment and version control, and hear about challenges and how they overcame those challenges. So let's roll the intro for Kirsi and Niko to welcome them on stage.
Hello, everyone, and greetings. Thank you for the great intro. So my name is Kirsi Louhelainen, and I'm a solutions architect at AWS in our Helsinki office, supporting our enterprise customers in their cloud journey on AWS platform. Today, we will be taking a look into how serverless solutions are growing and enabling faster, new, more scalable solutions, and how the operation looks with serverless. We'll be having as a case study our dear customer S Group, a major retailer in Finland, just as you just heard, which has created impressive developer organization and created a new service solution for the online food store, S-kaupat. From S Group, with me here today is Niko Kivelä.
Hello, my name is Niko Kivelä, and I'm, as said, working as a principal DevOps architect here at SOK, the central piece of regional cooperatives called S Group. The topic for today is serverless food, how DevOps feeds people.
So in the past 2 days, we've had many excellent presentations about DevOps, how to improve operations, and success stories from different companies and organizations. What all these stories have in common is the need to innovate, react more rapidly in the changing world, and the need to focus on what matters. Every company knows innovation is critical to their success, especially given the unprecedented pace of technological advancement and the need to be able to respond rapidly to the changing world. However, according to one survey by Deloitte, reality is in stark contrast to this need. CIOs say that 80% of developer time is spent on operations and maintenance of applications, and only 20% of the time is actually spent on innovation. What's the biggest barrier? Is the lack of time spent on what matters. Today, most of it is spent on operations and maintenance, whereas we would like to focus on innovation and speed. This is why serverless adoption is growing so fast. A serverless strategy enables customers to focus on things that benefit their customers, not on just infrastructure management. AWS pioneered the serverless with the launch of Lambda already 8 years ago. And today, hundreds of thousands of customers have built applications that already drive trillions of invokes per month. And it continues to grow at a phenomenal rate. However, serverless is a lot more than Lambda. There are already serverless services at all layers of the stack, and their number keeps growing. Our customers have adopted serverless solutions and demand more. You might just hear a little of those demands in the following presentation. Not only can you do compute with Lambda, you can also manage your containers with a serverless solution. We have serverless solutions for APIs, integration and orchestration, and storing, processing, and analyzing data. The latest additions to the serverless family were announced in the latest re:Invent serverless versions of data warehousing and processing solutions, Amazon Redshift, MSK, and EMR. And of course, combining these tools together is what enables fast building. And when these components come together to create cloud-native solutions is where we really start to see the big gains. To innovate, businesses need capabilities that help them move fast, build simply, and deliver rapidly to their customers. At AWS, we talk a lot about builders, and we see both developers and operators as critical builders in serverless first strategy. These roles are changing as customers move to the cloud, and our goal is to build capabilities that help both operators and developers to be successful And I think what is particularly interesting is the collaboration between developers and operations. How do they work together? As these new services change the way we do software, we need to learn new ways, and we have new operational responsibilities. Serverless might remove a lot of overhead in the maintenance, but it does definitely not mean that Ops is dead. Rather, it means there is a new role as supporter of the developers. And this is something we could all learn from Pioneer. So let me give the stage to our dear customer S Group and Niko Kivelä.
Thank you, Kirsi, for the great intro. And it's totally true what he said about serverless. It's not about computation anymore, but much more, as you will hear in my presentation. But let's start. S-kaupat is the groceries arm of S Group, the largest retailer in Finland. This is a story how we scaled from one shop to a network of stores just in 2 years. And with this, I mean that we didn't develop 200 websites, but we needed to develop new tools and processes for ordering, picking and shipping, and each store and personal. And when processes include people, it's not a technical issue anymore. We had a grocery selling webshop already, but we needed to do a full facelift, starting from underlying tech and tools around it. We wanted to become bigger, faster, and more humane. We started small, proof of concept, and tried a small campaign that sells crayfish, and everything went. But then suddenly COVID-19 hit the world, and the importance of people being able to order food online suddenly rocketed and ended our honeymoon. We weren't ready to deploy at that scale, but we did it anyway. In this presentation, I will tell you a story how we scaled from a proof of concept to a network of over 200 stores just in 2 years. Let's move on to more technical things. Microservices and serverless continue to be two of the most hyped terms in the industry, and I believe that serverless technologies make developers significantly more productive. But at least for me, it's still somehow mixing in terms whether we are talking about cloud functions, serverless frameworks, or serverless technologies in general. And if we are talking about technology, is it only function as a service, but also a database as a service, or whatever as a service, so you don't have to worry about underlying infrastructure anymore. Our application is mostly serverless. And when AWS will come up with a serverless search engine, I guess we are more than happy to adopt it. Architecture-wise, the usual CloudFront serves the static content, and the application part is based on Lambdas, which are powered by Apollo GraphQL. For backend, we use serverless.js framework, and for frontend, another flavor of it, serverless Next.js component. And if you picked that up, both of our front-end and back-end are running in Lambdas. The actual beef of this architecture is to have all the product data in denormalized form in DynamoDB database, so we don't need to do enormous joins when serving the data to the customers. I will talk about this more in the following slide. This architecture is actually a great example how in modern cloud era, traditional ops roles are no longer necessarily needed, but presented as specialized developers, and where the meaning of DevOps is shifting more towards cultural aspects and ways of working. Our cloud platform is not only handling the automatic scaling, but also runtime environments and is optimized for minimizing costs. And if it's said that DevOps brings people from Dev and Ops closer together, serverless does that to developers and infrastructure. But it doesn't remove the need, It just makes it easier. Before going to more cultural aspects, I want to show you one more cool thing that serverless has allowed us to do. The right side of our architecture diagram. This is our product pipeline with 2 external data sources. Kafka Stream that feeds us product data and personalization engine that's used together with our product search. AWS Fargate is pulling for new data and inserts it to a database. This is a highly scattered data since product sources are many and single product's data can come in pieces during the day. After gathering it, it gets denormalized, buffered through simple queue service, and is finally fitting to a next database in more usable form. From there, it can be used to display product data in our site, but also continue to be fed to our search engine in Amazon Open Search service. And this search engine is also the bottleneck of our architecture. It's not serverless. From time to time, we need to scale up our search clusters and actually restrict the number of concurrent lambdas writing to it, so we won't internally DDoS ourselves. Obviously, our site generates a lot of events. We are feeding these events to AWS Kinesis that are then sent to our personalization engine to be used in combination with our search and for product recommendations. As I said at the beginning, we have over 200 stores, and they all have their own products since we are working in 20 co-ops. Therefore, we can have as much as 50,000 product events in a second, making it millions a day. Another thing we need to consider is to limit the concurrent lambdas in general, so we won't reach the quota limits in our AWS account. What we learned while doing this? Monolithic means totally different thing in serverless and non-serverless worlds. We have organized our functionality in terms of microservices, and microservices are independently deployable services, small in size, modeled around business domains and communicated through well-defined interfaces. This kind of architecture is optimized for team autonomy. One microservice usually has many features like adding or deleting product in a shopping cart. In terms of cloud functions, it's usually mapped around 5 to 7 algorithms or cloud functions, or as AWS calls them, lambdas. Following old habits, some might think that each deployable service or function or functionality should be in its own code repository, like we used to do in the past. But think it through. About the repository strategies. Lambdas are independent. They actually run in isolated containers that someone else manages within the request lifecycle. So they are really independently deployable. But they also need to work together. A single algorithm rarely brings any value to the customer unless it's part of some larger microservice. And microservice rarely brings any value to the customer unless it's part of a bigger application that the customers can use. And that's why we decided to combine all the services to the same code repository. There are 2 main strategies for managing source code through Git: monorepo and multirepo. Both approaches have their pros and cons, but for us, after migrating to monorepo, everything has become so much easier. While each service still remains independently deployable, we can also deploy all of them from the same pipeline, and we tend to do it daily. We actually have a single source of truth, what was deployed and by whom, instead of having to go through separate sources and dashboards in case of an incident. But mark my words, monorepos are no silver bullet. They solve some things, but it doesn't come cheap. Tools need to be created to scale. It's a good idea to have a permanent team of DevOps engineers to keep it up.
Hi, we are Eficode and we organize the DevOps Conference. Delivering the benefits of DevOps through cloud gives the scalability, availability, and cost effectiveness we all want. We would love to speak to you to learn how we could help you to do DevOps better in the cloud. You can find us at eficode.com. The links are in the description. And have a great time with the DevOps Conference talks.
Technical things are just hard work, but you should do your best to automate everything. Every extra minute spent in CI/CD pipelines, setting up development environments or running linters in pre-commit hooks multiplies in number of developers and tasks they do. Focus on developer experience from day one. Lost trust in tooling makes them look bad on you and probably try to bypass your attempts to keep things in order. But once you have it and you are able to support developers with modern CI/CD practices like provisioning environments for each new development initiative on demand, we can start to focus on the main challenges. And as I said at the beginning, if DevOps brings people from Dev and Ops closer together, Serverless did it to developers and infrastructure. And this makes the role of DevOps finally shifting towards cultural aspects. The actual work comes or should come from how to support people with cultural building, continuous integration, and delivery and deployment capabilities, the cornerstones of DevOps. Next, I will tell you a bit how we are handling our daily work, especially from the DevOps side. Serverless allows us to focus on producing value to the customers. And that's what DevOps is all about. Optimize throughput, observe everything, learn and optimize from that so we can produce value even faster. We don't need to spend time adjusting our workloads because of serverless. We have defined our infrastructure as code in 3 layers. Static resources such as CDN, DNS and backups are defined with Terraform, since most of them are defined centrally elsewhere, and we do not want to reproduce them in each CI/CD pipeline run. Per environment resources are done with AWS CDK, since it's the most natural choice for our JavaScript and TypeScript developers, and most easily adopted. Functions are then defined with Serverless JS framework, provisioned and removed per deployment to support trunk-based development and continuous delivery practices. I will tell you a secret. Most of our production incidents are non-tech related. I'm not saying that technology isn't part of it, but the root cause usually lies in the design and processes given or made by the team. We have embedded blameless postmortem to be an integrated method in our toolbox. As some of you might know, they usually find something to be improved in our system, and that allows our system to become easily resilient, and so that kind of flaws won't happen again so easily. Therefore, we need constantly lower our bar on postmortems and have postmortems about even smaller and less significant things. I remember when we first started this, we had a postmortem with the topic S-kaupat.fi front page missing, and that was bad. Months later, after practicing and continuously improving ourselves, we had a session with the topic letter A with dots not accepted in text box, and that was just a great use of building good habits. I don't even know how many iterations we have done inside our ops squad, but history has proven that the best composition for it in our domain is a mix of DevOps experts and service management, so we can support developer efficiency and processes, but also with tooling and everything related to pipelines. Emphasis on a part developer experience. But serverless also turns some things upside down. If software development alone is complex, working in a team even harder, and adding a serverless abstraction of infrastructure on top of it easier, but not. We never wanted to be cloud agnostic. We went full AWS and for their specific technologies. It's much more acceptable for us to get the high value from the development straight away compared to prepare for potentially switching cloud providers later, which might and probably will not ever happen. Local development for Lambda-based application is okay, but we can only do it so far. There's always going to be problems you couldn't see coming, like problems with IAM permissions, configurations, and eventually consistent deployment pipelines, which you are probably going to be sharing with somebody else's code because functions are so fine coarse. Just to do development for Lambda, you probably end up using API Gateway, DynamoDB, SQS, S3, etc. So do your development in cloud too, and stop looking for trouble. Developers' time is the most precious resource in software development in general, and all time spent in something else than coding makes continuous integration more off-putting. Supporting them is a balancing act between reliability, speed, and predictability of deployments. The best approach we've found is to deploy only the services that have changed from our pipeline and use everything else from a previously deployed shared base that contains a stable version of our application that mirrors production. And to keep the shared base as close to production as possible, we update it after each deployment to production. Testing has also changed its nature with serverless. What to test, where, and how. We all know that automatic regression testing is necessary. It's needed. My recommendation has been that you use unit testing as a tool in development. Your code is read so much more than written. You writing unit tests for your code demonstrates your respect to other developers when you are building a safety net. You are probably not going to be the only one making changes to your code you initially wrote. But unit tests won't test your code in a way it's going to be invoked, which is a huge part in serverless ecosystem. If you only focus on unit testing your code, you are skipping a large part of your feature. Therefore, we've come to the conclusion that integration tests are the most cost-effective way for us to do testing, but that again requires tooling for preparing environments for it. But anyway, offload as much of the testing to cloud as possible and stop mocking your dependencies, because once you start mocking, there's no end for it. But write unit tests when it makes sense. It makes sense to write unit tests, at least for shared code and utilities. But allow yourself to question everything. if it works. Go against the testing pyramid if you find it useful. Lastly, the deployments are the final step that delivers the value to the customers. It's always a thrilling play to deploy multiple services consisting of multiple functions that are eventually and asynchronously deployed to production. Deployments aren't atomic because of the nature of the cloud. That's why we are encouraging our teams to deploy as soon as possible, all the time in smaller batch size, to make deployment smaller and more predictable. And the way to make it even more linear is to go for continuous deployment, which is more a cultural thing than a technical one. The point of this slide is to show you the diversity of our teams. But no team stays the same. We are guiding our teams with aligned OKRs, but that's it. Cross-functional teams are responsible for operating their services and functionality. We, as DevOps experts, support them in so many levels. We help functional teams to take the ownership of their application and improve it. I'm coming from a centralized DevOps function. We have a group of DevOps experts with different expertise, such as hands-on CI/CD strategies, monitoring and tooling, monitoring and processes around it, cloud infrastructure and tooling. This is also a very effective way spreading know-how around the company, since our DevOps specialists usually work with different teams at different times. This allows us to bring the needed capabilities timely while taking synergies to the maximum. I'm going to end my presentation with these discrete sentences. Microservice, Agile team autonomy, and DevOps team, and how they are tangled and connected, based on my experience. Distributed responsibility works, but distributed systems where teams own their services, the shared platform, including deployment pipelines, toolings for automatic testing and continuous monitoring, is usually owned more by some teams than others, and it always depends on time, context, and the need. While microservices is an architecture which optimizes for team autonomy, how would you define team autonomy? An autonomous team doesn't mean that team is allowed to do whatever it wants, or even not to do what they don't want. It means that they are responsible for solving the given problem in the most effective way. But no team is expert in everything. A jack of all trades is master of none, and usually mediocre at least some of the skills, and we don't want to settle for mediocre solutions. Teams can use some help time to time. If team is large enough, we can drop there 1 or 2 DevOps experts, but eventually they will also need peer support. And that's why we have centralized DevOps team. Our focus is to make developers more effective and let good practices spread from team to team. Think about us as an internal consultancy that's helping teams on a needs basis and joining teams as its team members for periods of time. There are so many things that are important for improving developer experience and effectiveness. Developer effectiveness is often called developer experience, because developers are the happiest when they can focus on the actual code and get everything else out of the way. Improving developer experience and effectiveness are the same thing. In other words, our DevOps is autonomous team that has the capabilities to do the needful. And serverless a better developer-friendly abstraction of good old virtualization, so we don't have to worry about it anymore.
Thank you, Niko, for the interesting and great presentation. That was a great story. And what's particularly impressive was how fast this group team was able to scale when the world changed around us. I wanted to wrap this up with a few points that we saw in operation in Niko's presentation. Some points that are critical to companies building modern applications. The 4 A's of modern DevOps are all visible in the success story. The accountability, removing silos, automating operations, monitoring, and allowing for autonomous teams while providing support, guardrails, and common guidelines. I'd say I was most impressed with the observation that incidents are not actually technology related, and that you actually have to have your service management people in the ops team. This is how it should be done. You are not working in silos, but you actually concentrate on bringing the most value to your own customer. I will skip a bit and go directly to the paradigm shift that we are witnessing. According to one study, there are 75% organizations in the study that are planning to use serverless technology within the next couple of years. In my own recent conversations with some of our partners, I was struck by how many of them said that serverless is already de facto starting point for building new applications for their customers. And other options were considered only when there was a clear reason to do so. This is all part of a bigger movement. We are in the middle of a paradigm shift. Cloud providers automate and abstract away as much as possible, which is in direct support of what business leaders want, to build better products and, of course, win more customers. I will summarize a few things that we heard in the previous great story that are related to the changing role of DevOps. The number one is, with cloud-native components, you can reduce custom code. You no longer need to build everything from scratch, import libraries, third-party products. This is the way you can minimize maintenance, as you no longer spend time to patching and updating. Infrastructure as a code changes the way you spin up new environments, enables you a whole new level of control over them. It also saves you money. Spinning new environments via IAC is very cheap and makes testing affordable, as you only pay for the time you need that environment. One thing I partly paid attention to in Niko's presentation was that with modern tooling, you can actually go from local testing to cloud-first development. As the IAC enables spinning similar controlled environments faster, you can actually start giving your developers personal cloud environments where they can test in a production-like environment. I mean, we've all been there, trying to test products locally, mock everything inside, only to find issues in the integration phase, right? But in this cloud-native model, you can ditch that and test directly in the cloud, and that is magic. Then, of course, cloud-based guardrails and common tooling will increase security and reliability. You can enforce uniform security configurations, versions, and monitoring capabilities over environments while giving your developers the freedom to experiment and spin new environments. A true developer-enhanced experience. Now, many of you are probably excited to get started. But how exactly? Not just developers and operators, but your entire organization need to learn new ways to do things and new methods to organize responsibilities. Who decides the guardrails for your development teams and handles security? How much freedom you'll give your developers, and what kind of collaboration do they have with the operations side? As you start your serverless and modern DevOps journey, you will need to recruit new talent and upskill your people. Certifications and training programs will help you to ensure your people have the necessary skills. You will probably also want to bring in partners that can help you reach your goals faster and bring in experience and best practices, lessons learned. And of course, you want to use that insight to build your organization to support new ways of working, from operations to procurement. As your first step, just a little reminder, you probably do something in the serverless world already because your developers have chosen fast tools to get started. So find those people, build a team, and choose something small that you can get started within a few weeks. And if you use tooling from experts and partners, just talk with us at AWS about upskilling your people and the local support you provide, and then concentrate on the long term. The benefits will be immediate, and your business will be able to create, innovate, and serve your customers much better. You can find my information here. There is a LinkedIn connection, and just drop me a line if you want to use, for instance, our office hours. And Niko, I think, has some really interesting links here for you.
Yeah, here's some links if you want to reach out. I've written actually quite many articles based on the same themes we just went through. We've also open sourced our common agreed ways of working as OK development guidelines, but also tooling and practices in our GitLab account. Go and take a look.
Thank you, Kirsi and Niko. I need to say, I think you are breaking records in terms of number of questions, but before we go to questions, I need to commend you on the openness around the development practices. I really, really appreciate that you have shared your lessons learned. Question number one is relating the cost effectiveness of serverless versus running microservices on EC2 instances. So beyond proof of concept, how did you evaluate that and confirm that it is a more cost-effective way to go?
So maybe I could first start and just explain that as with serverless, you pay as you don't pay for the bandwidth you don't use. And with EC2, obviously you can scale. You can have your auto-scaling groups and you can choose, you can observe patterns. But it is still the invocation of a Lambda is so much cheaper that it will likely, especially with the POC, be a better option for you. But I'm interested, Niko, did you actually make some sort of evaluation, or did you just go with your guts?
I think that the actual spend part is not always the main thing, but actually the total cost of ownership, whether you are saving a grant or not. Usually the Rockstar developers are not Linux admins and vice versa. So having a EC2 running in a cloud is always a security risk that requires different kind of experts. And I don't even know if this is a relative question, because the total cost of ownership for our developers it's something amazing.
I love that you brought the total cost of ownership, because people often, they just look into monthly spend, they look at how much they spend on infrastructure, and they forget they have a team of 10 people supporting all of this. And so Serverless allows you to reduce that overhead and concentrate on important things.
Great.
Yep.
Next one.
Yes, we have another question. When it comes to using a monorepo as the main application of your platform, how do you deal with the long build/compilation times for your release pipeline? Did you have to optimize any part of your release pipeline to reduce the time to production?
Well, totally. We have many DevOps experts in our team, and it needs constant support, because developers are going faster and faster every day, and we need to support them more and more every day. So that's something that we need to support them daily. But at the same time, even though it sounds that we are doing much, it's much better to do it centrally. Have your tooling and configurations defined once, instead of having 20 or 30 separate repositories and always out of sync.
So basically, you're not just optimizing for speed, but also for the uniformity and avoiding errors.
Okay.
Yes, as I said, single point of truth. The awareness of things.
We have 1 minute 30 for 2 questions. So if we're really, really quick, maybe we can cover them both. What kind of branching strategy do you use for monorepo? Trunk-based, Git flow, or something else? And what SCM tool?
We are using GitLab, and it's it's a good tool. It hosts our code and the CI/CD pipelines. We tend to go for trunk-based development, have short-lived branches, because the merge requests take a long time. Trunk-based development works towards itself because it embraces people to do shorter branches and merge them back to master. So the merge request is easier to handle and gets finally to production. But main thing that we needed to build was that we truly are able to provision environment for each branch on demand. And that's a crucial thing.
And then I'll quickly get that final question in. How do you deal with long-running processes handled by Lambdas? Do you have any processes that require more than 15 minutes to complete?
Yes, we do. Okay. And that was the AWS Fargate that's fetching data from Kafka stream. And for that we use Docker containers.
Docker containers, right.
Okay. We really crunched your question in, but I do like to thank you, Kirsi and Niko, for joining for the exciting presentation and taking so many questions in such a short time. If you have time, do stay back for conversations. But with that, we are moving on to our last speech. Thank you, Kirsi and Niko, again.
Thank you.
Thank you. It was a pleasure.
Thank you.